All right, we are currently in our weather unit and we are studying the question today of what makes wind happen. Wind is a part of the weather, a very important part of the weather that we've all experienced when we walk outside and we feel the wind moving and rustling the trees and blowing our hair and things like that. So, what makes all of that wind and blowing air happen? Let's go ahead and turn to page 270 in our textbook, please. Now remember, the atmosphere is the envelope of gases that surrounds the Earth. So we're going to start there. The atmosphere is a mixture of gases that surrounds Earth. We often refer to this mixture of gases as air. Although you cannot see it, air is matter. That means it's made up of molecules and atoms. Air moves from one place to another. We know this movement as wind. The atmosphere also contains small particles of liquid and solid matter such as water droplets, ash, and ice. The atmosphere is just one part of the larger Earth system. The Earth system also includes organisms in the biosphere. Organisms are just living things, water in the hydrosphere, and rocks and minerals in the geosphere. Describe how the atmosphere interacts with other parts of the Earth's system in each photo. Here we can see winter winds in the Krontovsky Reserve, Russia. Looks like the wind is blowing on this fox. So the wind is touching the fox. So the atmosphere contains the air and the wind, and it's touching the fox. The fox is a part of the biosphere because he is a living thing. Over here, it says hurricane in Baja California, Mexico. We can see also the wind is interacting with the trees here. Trees are living things, so that is a part of the biosphere. Also, you can see these buildings in the background are being affected by the wind as well, and there's a human there and a car in the background. So humans and trees are a part of the biosphere, so the atmosphere is interacting with the biosphere. Down here in this picture, it says wildfire in Santa Paula, California. Here you can see humans trying to put out the wildfire, and you can see the wind blowing these little bits of fire and ash around. The wind and the atmosphere are interacting with the biosphere. You can see that tree is on fire and the humans trying to put the fire out. Energy from the sun. The sun emits energy that travels through space and enters the Earth's system. Some of that energy can be seen as light, and some of it is invisible. Matter in the atmosphere and on the Earth's surface absorbs, reflects, and transfers the sun's energy. To understand why wind blows, you must first understand that Earth has temperature differences. Temperature differences occur because some areas receive more direct sunlight than others do. For example, the equator receives more direct sunlight than the poles. So the equator is generally warmer. Remember, the equator is like the belt around the center of the Earth. Earth's temperatures also vary because some surfaces absorb more energy than others do. For example, the oceans absorb more solar energy than the land does, and the land absorbs more solar energy than the air does. Surfaces also absorb and release energy at different rates. For example, land warms and cools faster than water does. So, let's go ahead and draw the sun right over here. Here's our sun, or part of it anyways. And let's go ahead and draw the Earth over here so we can get a better idea of why the sun, parts of the Earth might receive different amounts of thermal energy or heat from the sun. So we're going to go ahead and draw our Earth ball over here. And we're going to draw the equator sort of like, oops, you can't see that. The equator sort of like a little belt that goes around the center of the Earth. The equator is in the center, and we call that 0 degrees. Okay, 0 degrees latitude. So the poles are up here and down here. let's go ahead and label the poles. And this right here is our equator. Here comes some energy from the sun getting directly on the equator. And you can see how as we get closer to the poles, the sun's energy is coming in at an angle. So this part of the Earth isn't really getting as much direct sunlight as this part. That's why this part of the Earth, the equator region, tends to be warmer all the time because it's getting direct sunlight shining on it, more so than the poles. And the poles are colder because they're not getting as much thermal energy. That's why we have a lot of ice and snow on the poles. All right, we're going to go ahead and turn to page 271. Use a physical model to explain how differences in air pressure form wind. The motions of air particles cause the particles to run into each other and into objects on Earth. The force of the air particles pressing on other particles and objects is known as air pressure. So a force is just something that pushes or pulls. All right, we're going to go ahead and write some observations. Please go ahead and flip all the way down to the little observation sheet down here. Okay. And we're going to go ahead and label this that steps 2 and 3, we're going to say this is before pumping. And then steps 4 and 5 is going to be after pumping. So I'm going to use a model now to represent some air particles. And I'd like you to write some observations in here of what you noticed before I do something to those air particles. I'm going to apply some pressure. I'm going to apply a force to them by pushing on them. So here's a bottle, just a regular old plastic bottle. I have some marshmallows inside there, okay? There's a hole that I've poked in the side of the bottle, and I've covered it with tape to keep the air from escaping from the hole. On top, there's this little pressurizer that pumps air into the bottle. So you might have seen one of these that somebody had to sort of carbonate their drink or add bubbles into their drink. You can push on it, and you can pump the pump, and it will add air into here. It'll push air inside the bottle, okay? So right now, we're going to say that these marshmallows represent some particles of air, just little air molecules, okay? Let's describe what they look like, the shape of the marshmallows. Well, I'm going to go ahead and draw a picture of the shape of the marshmallow. It's a nice little billowy, little adorable pillow, sort of. We might say something like it's a cylinder, and it's smooth. Feel of the bottle. Well, when I squish it, look at that. It squeezes easily. I can squish it like that, okay? So we're going to say it squeezes easily. And the sound when you shake the bottle. Kind of sounds like a soft thud, huh? So we'll say it's just like a soft thud. All right, now I'm going to go ahead and push some air molecules into here by pumping the pump, okay? I'm going to zoom it out just a little bit, and I'm going to move the book out of the way so you can see what happens. And as I'm pumping, I'd like you to add some observations of the shape of the marshmallow, and I'll let you know how the bottle feels and the sound. This is after pumping, okay? So here we are. I'm going to start adding some air pressure or air molecules into the bottle. Let's observe what's happening. Let's see. All right, let me zoom it in a little bit so you guys can get a closer look at those marshmallows. Or, sorry, air particles as we're calling them right now. I'm going to keep pumping from the top here. Uh-oh, we're losing air. Let's see. Uh-oh. Hang on, we're losing air. All right. Sorry, I had to switch bottles because that one was not working. It was losing air. So here's a new bottle, and it's got the same hole in it, and it's got the same pump on top. And this one is not losing air, though. So we can kind of see something happening as I pump the air into the bottle. Take a very close look. Let's see here. Something is happening to those marshmallow air particles. Look really closely at the shape of them. I'm going to keep pumping. And as you can see also, it seems like there's less of them. There's less. They look like they're, maybe changing size as well. And they might be, their shape is looking a little different than the original marshmallows. So here's what the originals look like, right? Now these ones are looking a little different. Look at that. They kind of look like raisins. All right, look at that. The sound they're making against the bottle is different too. It's not as soft and thuddy anymore. It kind of sounds like little rocks in there. They're maybe like they're getting harder or something. Ooh, it's also getting harder for me to push the air into the bottle. And look at this. I can't squeeze the bottle anymore. It's really, really difficult to squeeze the bottle. All right, let's make some observations. What's the shape of them now? They kind of look like raisins. They're a little bit wrinkly. They're not soft and pillowy anymore. Like, let's compare. These ones are soft and pillowy. These ones look like little raisins. They're like wrinkled up and smaller. And the sound, very difficult. Okay, soft thud. So make sure you write down some observations on your sheet about the shape of the marshmallows, the feel of the bottle. It's hard to squeeze now. And I'm going to just maybe draw in. They look a little sad, like a raisin. Raisin-shaped. Wrinkly. And the sound of the bottle sounds sharper. Okay, we're going to change the page. We're going to flip to the next side. And it says, predict what might happen if you remove the tape from the hole. Before doing so, tip the bottle horizontally and shake it to distribute the marshmallows evenly over the surface. Okay, what do you predict is going to happen when I remove the tape from the hole? I'm holding the tape down right now. What do you think is going to happen? Please write a prediction right there. I'm going to go ahead and pause the video for a moment so you can write a prediction as to what you think is going to happen when I... Wow, look at that. There's hardly any in there anymore. See this line? That's where the marshmallows used to be. Now they're like way below the line. Like they're so much smaller than they were before. Okay, remove the tape and describe what happens. So I'm going to remove the tape. I'd like you to write some observations. Here we go. Oh, let me get this out of the way so that we can see. All right, here we go. Uh-oh, do you hear that? Whoa. What's happening? Do you hear that hissing noise? It's hissing. Well, it was. It was hissing. And look at the marshmallows. Look at this. Look at how big they are again. They're all the way up to the black line again, too. In fact, they sort of look just like they did before now. They're soft and billowy. Please make sure you record those observations on page 272 in this section. we might say something like hissing noise. Mallows ballooned out to their original shape. I could feel the air coming out of the hole on my finger. So the air was moving fast. Air rushed out super fast. Very fast. All right. You pumped air into the bottle, so the air pressure in the bottle was greater than the air pressure outside of the bottle. Explain how this experiment models the relationship between air pressure and the formation of wind. So what we're going to do is draw a quick little picture that explains the entire process. Go ahead and draw a little bottle. We're going to draw our little bottle here. And we're going to say high. We're just going to spell it like that, H-I, high air pressure. Because I pumped a whole bunch of extra air molecules in through the top because they're of the pump, right? So we added a lot of air molecules. So there's super, super high pressure inside. Outside of the bottle, there's not very much air pressure. So we're going to say that's low air pressure outside of the bottle. And we're just going to spell it L-O, okay? So high air pressure on the inside, low air pressure on the outside. Maybe we'll draw in a whole bunch of air molecules, like squeezing in. These are the air molecules squeezing in, pushing on the sides of the bottle, making it super hard to squeeze the bottle because they're pushing on the sides, right? Then we removed my thumb and the piece of tape from the side. And here's our hole. We're going to exaggerate how big the hole is. And then when I removed the tape, the air molecules were trying to escape super fast. They wanted out of there. So we're going to say that that is what we're going to call mallow wind. We made some marshmallow wind. This is how wind forms. So we're going to say air moves from high pressure to low pressure. So air moving from high pressure to low pressure zones, this is what we call wind. So we'll say this is wind. This movement of air that we just observed. We just made marshmallow wind. All right. At any given time, there are air pressure differences all around the Earth. As air gets warmer, it expands and its density decreases. So warmer means density is decreasing or getting smaller. So things are getting less dense as they're getting warmer. Density refers to the mass per unit volume of a material. That just means basically how heavy something is for how much space it takes up. Kind of like the little bottle of salt that I had compared to the little bottle of cotton balls. They're the same exact size, but one of them was much heavier even though they were the same size. The one that was heavier was more dense. High pressure air flows toward low pressure air, causing wind. Please box that entire sentence. That's the whole key right there. In this experiment, the higher density of air particles in the bottle represented an area of high pressure. The air flowed out of the bottle because the air pressure outside the bottle was less dense and therefore had a lower air pressure. In the diagram below, the column of air on the left represents a specific volume of cold air. The same volume of warm air is shown on the right. Draw an arrow in the box to show which direction the wind would blow. So, what do you guess? Do you think the wind is going to go in this direction, from high pressure to low pressure, or do you think it's going to go in this direction, from low pressure to high pressure? Go ahead and put your arrow in now. Pause the video if you need to, and then return when you're ready. All right, so we're going to label this as cold. So this is cold air. And we're going to say this is high pressure. High pressure, because there's lots of air molecules bounced into this one little spot, right? So this is high pressure. Then over here we've got low pressure, low density. Okay, so this over here would be our warm air. Cold air and warm air. So we're going to label this as low density. So if wind blows, let's write this down, from high to low, which direction is it going to go? It's going to go in this direction. It will go that direction because this is high pressure, this is low pressure. There's not as many air molecules packed in over here, so these ones are getting really crowded over here, and they're like, oh my gosh, let's find another place so that we can spread out a little bit. So they want to get out of this air pressure zone and go to some place that's not as crowded. So that's why the wind is blowing in this direction. We're going to go over to page 273. Cool, dense air sinks to the Earth's surface and spreads out. As it spreads out, it pushes away warm, less dense air. This causes the warm air to rise. The cool air, now at the surface, begins to warm up. The warm air that was pushed up begins to cool and become denser. If it becomes denser than the surrounding air, it sinks back towards the surface. This cycling of matter due to differences in densities is called convection. So we're going to go ahead and draw a quick picture of that over here to sort of visualize what this paragraph just said. So we're going to say we have warm air rising. So please label warm air rising, because the ground is warm because the thermal energy from the sun has heated up the ground. So we've got the air right above the ground rising and going up in the upward direction. And it's really cold up here. So we're going to say high up in atmosphere is cold. So since it's super cold up here, those air molecules begin to condense, as we discussed when we discussed condensation. They're slowing down, they're coming together, and then when they come together, that makes them more dense. So now we're going to say cold, dense air sinks because it's heavier than the air around it. So it's going to go in this direction. As this cold, dense air hits the bottom of the earth and hits down below, it spreads out in different directions, and it goes and moves and pushes that less dense warm air out of the way. And we're going to say wind pushes warm air. There we go.